Alright, welcome back to another exciting CollaVision video. This one is on doing molar conversions. Here's that little chart I made in the last video to kind of help you get used to converting moles and things like that. And it really does come in handy. And once you get used to it, you probably won't use this chart anymore. But when you're first learning, it does work pretty good. And it shows you the significance of moles. If you notice, moles is dead in the center. So you can convert from grams to atoms if you wanted to, or atoms to grams, but you're going to have to go to moles to do it, or even to a volume down here for a gas that we've got in this. And again, this is volume for a gas that we're talking about in this. Let's go back and do another example. I'm going to do this one. This problem here says, how many sulfur atoms are in 1.50 moles of sulfur? So this one starts me out by writing like this. It says that I've got 1.5, I'm going to try and write, as soon as my pen starts working, 1.5 moles of sulfur. I'm going to draw my line, put my X, and draw my line. It's just like converting inches to feet. So this one gives me moles of sulfur, but it's asking me to find atoms. So it's starting me in moles, asking for atoms. So I'm going to have just one step. This is going to be a one-step problem, from moles to atoms. And my conversion factor I love, because 6.02 times 10 to the 23rd, if you take a look at this, it doesn't ever change. It's always the same conversion factor. 1 mole of anything contains 6.02 times 10 to the 23 particles, atoms, units, or molecules that it's got in here. So in this case, I'm going from moles of sulfur to atoms. So my conversion factor is for every 1 mole of sulfur, there's 6.02 times 10 to the 23rd S atoms. And now all I need to know is where does what go in here? Well, if mole S is here, mole S has to be on bottom in the next step. So I'm going to write 1 mole of sulfur on the bottom here, and I'm going to write 6.02 times 10 to the 23rd sulfur atoms up on top of this next line. I'm going to finish this out, and equals. I am done with that problem. So all I need to do is go to my calculator now, plug in these numbers. So this is 1.5 times 6.02, 10 to the 23rd, and I've got 9.03 times 10 to the 23rd. So 9.03 times 10 to the 23rd. And watch how I write my answer out. Times 10 to the 23rd S atoms is how I'm going to write this out. I'm going to put my box around it so that it doesn't get confusing. So anyway, there's how I do this one. I'll tell you what, we've done a bunch of one-step problems. Let's take 1 second, though, and I want to explain one thing off of this chart. Some people don't understand when do you use atoms, when do you use units, and when do you use molecules over here. Well, I guess we could do a couple examples real quick. Atoms is for when you've got like the one we just did, like just S. Maybe Na. Maybe you've got, I'm trying to sit here and think, B. When you've just got an atom, when you've just got an element. So how do you know when you're going to use a unit? Well, use the word units or units when you've got something that's ionic. So if you've got like NaCl, you would describe that. NaCl would use units for that one. Maybe if you had, NH4, 2SO3, we would use units. It's ionic. So we'll use the word molecules. We'll use the word molecules whenever something's covalent. If it's covalent, we'll use the word molecules to describe it. And sometimes textbooks will start this chapter out by just giving you things and saying, is it an atom, is it a unit, or formula unit, some books will use, or is it a molecule? So like carbon dioxide. Carbon dioxide would be a molecule. It's a covalent bond. Carbon tetrachloride. Again, covalent bond, so you'd call it a molecule. So anyway, so let's go on and do another problem. Check this one out. It starts you with 25 grams of NaCl, and it asks you for units in this. So take a look at this problem. Starting you with 25.0 grams of NaCl, and it wants you to convert 2 units. So it's starting you in grams, and it's asking you to go to particles. This problem is going to have 2 steps. 2 steps in this problem to get from mass all the way to particles. So step number 1 is I got to convert to moles. So for NaCl, I've got to know how much does NaCl weigh per mole. So in other words, here's my question. 1 mole of NaCl would weigh how much? How much would a mole of NaCl weigh? Well, Na weighs 23 times 1 is 23. Cl is 35 times 1 is 35, which is 58. So that's how you get your conversion factors. You've got to always figure out your own conversion factors to do this mass to moles conversion in here. So I know that my conversion, this problem now is going to be, there's 58 grams of NaCl, and that's got to go on bottom. Grams NaCl is on top here. Grams has to be on bottom in the next step. So 58 grams of NaCl per 1 mole of NaCl. Now, I'm not going to put an equal sign because I'm not done. This problem asks me for units, so I need 1 and 2 steps in this problem. So I'm going to put an X, I'm going to put a line in there, just like that. So now, it said get 2 units. Suddenly feel the need to do an Arnold Schwarzenegger quote. Get to the chopper! Okay, I'm better now. Alright, now that that's out of my system. Now, to get this last conversion done, I love this last conversion. 1 mole of anything is 6.02 times 10 to the 23rd particles. So 1 mole, and I'm writing 1 mole of NaCl on bottom. Reason why? NaCl was on top there, so I've got to put mole, so that it cancels. For every 1 mole of NaCl, it would contain 6.02 times 10 to the 23rd NaCl units. I know it's a lot to write out, but I'm done. Put your equal sign, 2 steps. So in the case of this one, it'd be 25 times 6.02, 10 to the 23rd, divided by 58, 2.59 times 10 to the 23rd NaCl units. Now I got to draw me a big old beefy box around all that. Don't know where that little random squiggle came in there, but anyway, 2.59 times 10 to the 23rd NaCl units. So that's my answer to that. Let's do one more. Let's say that a problem were to start you off in volume. We haven't done one yet. So let's say you've got a problem with a gas. I'm going to try and see if I can kick my camera. There, that works really good for me. So let's say that we've got a problem. What about if it did this? What if it started us out with, let's say, like 8 liters of hydrogen gas? So let's say we start with 8 liters of hydrogen gas. Notice how I put my little 2 on there because this is hydrogen and it's going to buddy up in there. So hydrogen gas, 8 liters of hydrogen gas. So this is starting me off in liters. And let's say it wants us to find grams of hydrogen. Well, you should already be able to tell me how many steps is there going to be. There's going to be 1, 2 steps in this problem. Pretty much your intro chapter is always just 2 steps is as big as they get. So step number 1 is to convert to moles. I love this conversion factor. If it's at STP, the conversion factor is 1 mole to 22.4 liters. So I'm going to write 22.4 liters of H2 on bottom and 1 mole of H2 on top. I'm going to put my X and draw my line because we've already said that this is going to have 2 steps. First step, to get to moles. Second step, get to mass. Well, all I need to know is, what's your relationship of moles to grams for hydrogen? So how much does hydrogen weigh? How many grams of hydrogen are there in a mole of hydrogen? Well, we can figure it out. Hydrogen weighs 1 times 2 is 2. So there's 2 grams of hydrogen in a mole. Where does the 2 grams go, top or bottom? Well, moles has to be on bottom of the next step. So we'll write 1 mole H2 to 2 grams of H2, and we are done with this problem. So all we've got to do is look across top. 8 times 2 on top. So we've got 16 divided by 22.4. I'm going to go ahead and take a guess before we hit this. 16 divided by 0.77. 0.71. Dang, so much for my guess. I got pretty close though. 0.71 grams of H2. And I'm going to put my box around that. And this is pretty much how to do molar conversions. Again, these two have constants, so that's what makes any of these conversions easy over here. If you're doing the mass conversion, though, you've got to fill in that question mark. What does something weigh in order to make your conversions? Anyway, I hope this helps, and this concludes this video. So, good afternoon, and thank you, good sirs, and my